Hello students, today we will discuss our next article, that is Coulomb's law in electrostatics. Students, we know that in our previous lectures we have already discussed that two like charges repel each other and two opposite charges attract each other. Now, how much is the force with which these charges attract or repel each other? Now, the first of all, the expression which is used to measure this force is given by a scientist named as Coulomb, and hence this expression is known as Coulomb's law in electrostatics. Now, what is Coulomb's law in electrostatics? According to the Coulomb's law in electrostatics, the magnitude of the force of attraction or repulsion between the two static charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Students, we have already discussed that. Let us consider this is a positive charge and this is also positive charge. Then both the charges are like charges and hence they repel each other. Let this charge exert a force F on this charge, and similarly this charge also repel this charge with the same force F. Now, if both the charges, point charges, are opposite, then we know that opposite charges attract each other. So this negative charge that exert the attractive force F on this positive charge, then this positive charge also exert the same force on the negative charge. Hence, we find that these forces, which may be repulsive or attractive, they are equal. They obeys the Newton's third law. Now, question arises, how we can calculate these forces? The force which is present between the point charges, which may be attractive or repulsive, how we can calculate it? So, to calculate this force, consider 2 point charges Q1 and Q2, which are separated through certain distance r and placed in vacuum, air or free space. तो स्टूडेंट्स, हमने क्या किया? हमने दो चार्जेस कंसीडर किए, Q1 एंड Q2 आर प्लेस्ड एट डिस्टेंस r. डिस्टेंस r दूरी पर रखे हुए हैं. कहां पे? आइदर इन एयर और फ्री स्पेस और वैक्यूम. एंड let the force F is present between these 2 point charges, then according to the definition of Coulomb's law, this force F is directly proportional to the product of the magnitude of the 2-point charges, that is F is directly proportional to Q1 and Q2. This definition of Coulomb's law, it having two parts. One says that this force between 2-point charges is directly proportional to the product of the magnitude of the two charges. That is, F is directly proportional to Q1, Q2. Equation number 1. Now, according to the second part of this definition, this force of attraction or repulsion between the 2-point charges is also inversely proportional to the square of the distance between the 2-point charges. Therefore, we can write F is inversely proportional to 1 upon r square. Equation number 2. Now, from these two equations, equation number 1 and 2, we can write F is directly proportional to Q1, Q2 upon r square. Or, when we remove the sign of directly proportional, then we get a constant. We can write F is equal to K Q1 Q2 upon r square, equation number 3, where K is the constant of proportionality. K क्या है? Constant of proportionality. Now, if we consider the SI system of unit and the medium in which these two charges are placed, either air or vacuum or free space, then the value of this constant K is equal to 1 upon 4 pi epsilon naught. And if we put the values of pi and epsilon naught, then the value of K comes out to be 9 into 10 raised to power 9 Newton meter square Coulomb inverse square. Now, अगर हम पता करना चाहें भी ये जो यूनिट्स हैं ये कहां से आए, तो that is from equation number 3rd. From equation number 3rd, F is equal to K Q1 Q2 upon r square. Now we have to calculate the units of K. So therefore K is equal to F r square upon Q1 Q2 units. So in SI system, unit of forces Newton, unit of distances meter square, unit of charges Coulomb. This charge also have Coulomb, that is Coulomb square, और जब ये ऊपर जाएगा that is Coulomb inverse square. So the unit of K is Newton meter square Coulomb inverse square. Where therefore K is equal to 1 upon 4 pi epsilon naught, and the value of 1 upon 4 pi epsilon naught is 9 into 10 raised to power 9 Newton meter square Coulomb inverse square. Where epsilon naught is the permittivity of free space or air or vacuum, and it is also known as absolute permittivity. Epsilon naught is also known as absolute permittivity, and its value is 8.854 into 10 raised to power minus 12 Coulomb square, Newton inverse and meter inverse square. Again, अब देखिए इन यूनिट्स को हम रट्टा मार के याद नहीं रख सकते. तो अब देखिए यहां पे there is a very good technique to remember the unit of this epsilon naught. Here K is equal to 1 upon 4 pi epsilon naught. So this 1 upon 4 pi epsilon naught is, this is constant, so K is equal to, that is constant upon epsilon naught. It means K is inversely proportional to epsilon naught. It means K and epsilon naught are inversely proportional to each other. They are inverse of each other, and hence their units will also be inverse of each other. So unit of K is Newton meter square Coulomb inverse square. So therefore the unit of epsilon naught will be the inverse of the unit of K. That is Coulomb square, inverse है, square हो गया, and Newton inverse and meter inverse square. That is Coulomb square, Newton inverse, meter inverse square. इसको आप ऐसे याद रख सकते हैं. So when we put the value of K in equation number 3, then equation 3 becomes F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So this is the expression which is given by the coulombs to determine the magnitude of the force which is exerted by the 2 point charges on each other. This force is known as Coulomb's force or electrostatic force. Now students, there are some points, special points which we have to know. That is, first note is this constant K is known as electrostatic force constant. इस कांस्टेंट K को क्या कहते हैं? इलेक्ट्रोस्टैटिक फोर्स कांस्टेंट और कूलम्ब्स कांस्टेंट. K is Coulomb's constant or electrostatic force constant. And the second point is the value of K depends upon two things. Number one is on the system of unit, and number two is in which medium, or we can say what is the nature of the medium in which the 2 point charges are placed. That is, the value of K depends upon the nature of the medium and also on the system of unit. Now, point third, that is both point charges exert equal force on each other. मतलब जितना एक चार्ज दूसरे पे फोर्स लगाएगा उतनी ही फोर्स उस चार्ज पे भी लगेगी. They exert equal forces on each other. And this force which is calculated with the help of Coulomb's law, this force is known as Coulomb's force because it is calculated by the scientist named as Coulomb. So this force is known as Coulomb's force, and this force is also known as electrostatic force because this force is present between the 2 point charges, 2 static charges, and hence it is also known as static force. So F is Coulomb's force or electrostatic force. And the dimensional formula of absolute permittivity epsilon naught, this absolute permittivity, इसका जो dimensional formula होता है, that is m-1 L-3 T4 A square. A for ampere. And the last point is in CGS system, the value of K, value of इलेक्ट्रोस्टैटिक फोर्स कांस्टेंट K, वैल्यू ऑफ कूलम कांस्टेंट K इज 1। अगर हम सीजीएस सिस्टम लेके चलते हैं तो K की वैल्यू आती है 1। So students, this is all about the Coulomb's law in electrostatics. Thank you very much.